All right, the last shape we're going to study is a kite. Okay, so we're all pretty much familiar with what a kite looks like. A kite is very similar to the rhombus family. It has very traits that are similar to a rhombus. The first part of a kite, which is kind of hard to describe, is that it has two consecutive congruent sides. Okay, and I think you know what this means. It's just kind of hard to put into English. Two of the sides of a kite are going to be congruent. So it's this side and this side, and this side and this side. But the sides opposite are not congruent. So opposite sides are not congruent. So you just have to remember that with a kite. Okay. The second property is in a kite, it has one set of opposite congruent angles. And now where short side meets long side. Okay, if that's the best way to remember it. So where the non-congruent sides are, those angles will always be congruent. Okay, and we'll talk a little bit more. And the third property, which is already written on our paper, is that the diagonals in a kite are perpendicular, which is very similar to a rhombus. And what happens here is you'll see this right triangle, which has this tick mark and this tick mark, and because they share this piece, these two triangles are congruent by hypotenuse leg. These two triangles down here will also be congruent because of the hypotenuse and the leg. So you have two congruent right triangles here, you have two congruent right triangles here, but please remember these triangles are not the same as those triangles. So now let's look at an example of what we might have to do. First one, or in any kite problem, they may ask you to find the interior angles. Well, if you look at the kite, they're showing this piece is congruent to this piece, so that's my top. These two pieces are congruent down here, which means where short piece meets long piece are the same. So now I know that's 88. So you do have to pay attention that you know they're congruent, but not these. And then we have to come up with how am I going to figure out what the missing side is. So the missing side is 360 minus 107. Mine is 88 minus 88. And that answer would be 14 degrees. Please remember where I got 360 from. It has four sides, makes two triangles. 2 times 180 is 360. So this would be 14 degrees. All right, let's look at the next one. Find the side length of the kite, and I give you the inside diagonals. Well, what I realize here is I know that this is a right triangle. Well, if I have a side length here and a side length here, and I'm missing a side length, yes, you could use trig if you had angle measures, but we don't have any angle measures. So what can we use when we have side lengths? And pay attention, it does say simple radical form, which means no decimals. So now I'm going to look, and I have 2 squared plus 6 squared equals x squared. Correct. We're going to use Pythagorean theorem. So 4 plus 36 is 40. 40 equals x squared. Square root 10, 4, 2, 2, 2 root 10. So my outside here is 2 root 10. I know this is 2 root 10. Now I got to do Pythagorean theorem again with 2 squared and 4 squared equals x squared. 16 plus 4 is 20. Square root of 20, 10, 2, 5, 2, 2 root 5. So then I get 2 root 5 for the outside. So we do need to realize that there's right triangles in the middle of a kite. You have to realize the outsides, you're going to have 2 that are the same and 2 that are the same. All right, so it just looks pretty similar. I have a kite here. How do I know a kite? Because the two bottom are the same, the two top are the same. BD is 10, something I want to talk about. We talked about if this is 10 and I know these two triangles are congruent, remember this would be 10, so then if these are equal, you would know that this and this are 5. AE is 4, and AC, be careful, AC is 12, 11, 10, 9, 8, EC is 8. So now if I want the perimeter, it doesn't say how it wants it, so I'm guessing you're allowed to use a decimal. So I'm going to do 5 squared, 4 squared equals x squared, and I'm going to do 5 squared plus 8 squared equals x squared. So go ahead and try that. So if you did that, pause the video, you would have got the square root of 41, and I used a decimal, otherwise it's going to be ugly trying to add these together. So square root 6.4, I got square root of 89, square root of 89 is 9.4, and to do the perimeter, I'm going to take these together, and I get 31.6. Okay, so that's a kite problem. And let's look at this one, which has a little bit more. It does have an angle measure, which means there's a good chance I'm going to use trig. So let's check it out. All right, one thing I do know is that this is 90. And now if this is 90, that's 30. I know this is 60, 60, 30. If this is 90, I do know that these are 50 if I need them. BE is here. I have no value except that this is 5. So I actually have to come in here, and I don't have any other thing except this is 5, 90, and this is 40. So in order to find this side, I'm going to have to use trig. I'm going to put x here. I know from 40 degrees, it's opposite over adjacent. So this is tangent of 40's x over 5. I'm going to take tan of 40 and times it by 5 and get 4.2. I'm going to call that. Then BA is here, so I could put a y here. I could use trig again. Opposite, I have adjacent and the hypotenuse, so I'm going to do cosine of 40, 5 over y. That's the one where you're going to take 5 divided by cosine of 40. And I'm going to get 6.5. ABE is 50. ABC is 110. Perimeter means I have to find this. Now, it is a 30, 60, 90, so in theory, I know this is 8.4 because if across from 30 is 4.2, across from 90 is 8.4. So I know that's 8.4 and 6.5. 6.5 times 2, 8.5 times 2, 29.8. Area of just BEC, which is a 30, 60, 90, area of a triangle is 1/2 the height we know is 4.2, and of course we don't have the other leg, which is 4.2 root 3. You could make, I'm just going to put 4.2 root 3 because I know it's a 30, 60, 90. Now, if I want the area, I can multiply it all together. If I just multiply them all together without the decimal, I get 15.3. If I multiply them all together, keeping the decimal, you get 8.8 root 3. I don't really care which answer. It depends. Right now, it's not asking. You could have also, instead of using this side right here, I'm trying to show you here, instead of using that as 4.2 root 3, you could have just used trig. I just used the fact it was a 30, 60, 90, and if the short side's 4.2, the long side's 4.2 root 3. All right, so I hope that was enough for kites. Like I said, just remember the properties. Fill in your flow chart. I think I did send out a final flow chart. You'll see here it has 2 sets of congruent consecutive sides, 1 set of congruent opposite angles, and diagonals are perpendicular. Okay, so you got to be able to tell the difference of these. We're wrapping up our units on quadrilaterals. Thanks, guys and girls.